Welcome. Today's talk is Easy 2D Game Creation with Arcade by Paul Vincent Craven. Please give him a warm applause.
Hi, can you hear me okay? All right, I'm Paul Craven. Today I'm going to show you how to create 2D video games with Python and the Arcade library. You can explore and get more information available online by going to arcade.academy. There is a ton of information on this website. It's designed to get you up and going, creating 2D video games as fast and painlessly as possible. There's also a link to the live versions of these slides, so if you want the source code close by or follow any of the links, you've got that available. In order to get started, you need to install the Arcade library. You can install the Arcade library like pretty much any other package on PyPy, usually just typing pip install arcade, or for like Mac, Linux, pip3 install arcade will work just fine. Arcade does require Python 3.6 or greater. We use type hinting and some of the new features in the language. You also need some sort of hardware with OpenGL support, but really for almost any semi-modern hardware, that's not a problem. For further installation instructions, you can see the link there. If you want to create a game, well, the first step is to open up a window, and you need 3 lines of code in order to be able to do that. First off, import Arcade. Number 2, call the open window function. All you need to do is give it the width of the window, the height of the window, and a title for the window. Now, actually with just these 2 lines of code, it would open up a window. But since your program's done, it would open up a window and then just go away really fast. You'd barely be able to see it. So that's no good. We need the 3rd line of the code. The 3rd line of the code will keep the program running until you hit the close button. That arrow is where we're going to eventually start putting in some drawing code. Let's get set up for drawing. To get set up for drawing, we need 3 more lines of code. First, we need to set the background color. So when the screen gets cleared, what color are we going to clear it to? You can use named colors. You can also use a tuple and give it amount of red, green, and blue if you want an exact color. Step number 2, we need to tell the computer to clear the screen to the background color and get ready for drawing. That's the start render command. All our drawing commands are going to go where that arrow is. Once we're done drawing, call finish render. That will flip the screen and we can see what we've actually drawn. Nothing of what we've drawn is actually shown until you run finish render. Okay, let's actually get something to draw. We're going to create something simple like a smiley face. We need a yellow circle for the face and 2 for the eyes, and an arc for the mouth. Fairly straightforward. Here we have the 4 drawing commands for the smiley face. I've gone ahead and declared variables so that it makes it easier to see what I'm actually calling the function with. But just for the record, when you declare variables, you should declare them on their own line, not use semicolons, but it's really hard to get all the stuff stuffed onto the slide without using semicolons. We use 3 draw circle filled commands, 1 for the face, 2 for the eyes. The 1 for the face, you can see, basically we have a 600 by 600 window, so if we draw the face at 300, 300, we've got our circle in the middle of the window, and a radius of 200 pixels. We use an arc for the smile. The arc is one of the more complex drawing commands you can use because you need to give a width of the arc, a height of the arc, a start angle that you want the arc to start at, and an end angle that you want the arc to end at. But that gets us our smile. And you can see the full code for this at the link that's at the bottom of the slide. There are several different drawing commands that are available for use in drawing primitive shapes. You can draw rectangles several different ways depending upon how you want to specify the coordinates. You can also draw arcs, ellipses, lines, polygons, triangles, text. You can rotate any of these as well just by adding in a rotation parameter. Textures allow you to load an image from the disk, display it on the screen. You can look up any of the details for these commands online at Arcade Academy, and they're pretty straightforward to use. Now, even with drawing primitives like that, it's possible to create some pretty interesting images. These are all images from students that I had who were just like 2 weeks into learning how to program. They basically get experience working with variables, working with numbers, coordinate systems, calling functions, looking up documentation. And it's a great way to start, but even for expert programmers, it's kind of fun just to be able to easily whip something together and create some art. But wait, it's way better programming if we take our code and put it into functions, because we don't want to leave our code all strewn about in some sort of global context. We want to put our code in functions. And we want people to be able to look at our image and say, hey, not only is this image good, but we're coders. We want people to say, hey, that code is beautiful too, right? Okay, so this is an image that I've got that has a couple functions, one for drawing trees, one for drawing a couple birds up there. Let's take a look at the tree drawing function. This example for drawing a tree out of the previous image, I've got line number 1 up here defines the draw tree function. And this is where if you name your code functions really well, your code becomes self-documenting. Even a non-programmer can look at this and say, hey, well, if the function name is called draw a pine tree, there's a good chance that this has something to do with drawing a pine tree. Line number 2, let's draw a dark green triangle for the top of the pine tree. I need 3 x, y coordinates for a triangle, 1 for each point in the triangle, and I base where that is on the x, y that was given on where this tree should go. So that's the top of it. The bottom of it is a simple rectangle for the brown trunk. If you're new to programming, this is a really good way to practice defining functions, practice taking in parameters, all while building up a library of different things that you can display in some sort of game. The main function we need basically in order to start our game. So we've got all the drawing functions. How do we actually put the main part of our code into a function? And I've done this on step number 1. I've defined a main function. Step number at the bottom, what step number is that? I can't see. Anyway, step number 2, at the bottom I think it is. I'm actually calling the main function. I don't want to define the main function and then not call it, because nothing good will come out of that, or nothing at all, right? You could just call main with the open close parentheses. That would be fine. The if statement gives me the ability to import this module and not actually run the module if you want to keep the if statement. Looking at the middle section there in step 3, I'm calling all my functions at draw. Again, good named functions. A non-programmer can look at this and have a really good idea of what's happening. Okay, but if you're an experienced graphics programmer in the audience, you're probably looking at this and going, wait a minute, everything of what I've showed you is actually a really slow way of drawing. Think about it. If you wanted to draw in a game a star field of something with 200 stars in it, so you wanted to draw 200 stars, games normally run at 60 frames per second? So that means every 60 times per second, you're going to need to draw 200 stars. That's 12,000 stars being drawn per second. It's much faster if I take those 200 stars, load them onto the graphics card, and then say, hey, graphics card, those stars, draw them now. That takes 12,000 drawing commands down to 60 drawing commands. Arcade supports this as well, and it's really worth looking into. Okay, we want to make our program into more of an interactive game. We can use classes. You can also use decorators. I just don't really have time to cover that in this talk. If you take, on step number 1 here, I've defined my own class. I've called it PyGame, and I'm deriving it from Arcade's window class. Then, all I need to do is override functions that are built into the window class, add the functionality that I want. Step number 2, I'm adding functionality to the init function. So this is, well, with any class where you define all your instance variables. Step 3, in our setup method, this is where you're going to want to create your characters, make your walls, your platforms, your spaceships, your unicorns, whatever. That's where you put that in the setup function. You don't typically put it in the init function. If you put it in the setup function, if you ever want to later on allow the user to restart the game, then all you need to do is call setup again, and, well, you're set up. Step number 4, all the drawing code goes in that particular function. So right after the start render, that's where we're going to put our drawing code. Okay, continuing on. The update function is where we put the code to move the objects in our game and run another game object, like logic, like detecting collisions, that type of thing. It is important, keep the game logic code separated from the game drawing code. We can respond to user input if we want by overriding the other functions. Anytime the user hits a key, that's item 2, it's called. Anytime the user moves the mouse button, the on-mouse motion button is called. Anytime the user presses a mouse button, the on-mouse press button is called. There's a template for getting started with a game that's interactive like this. It's at the URL down at the bottom, and you can use that to start and basically fill in the code that you want to run. I should note, if you haven't seen it before, if you're new to programming or at least Python, the pass keyword is what we use when we need code, but we don't actually have code. So it's really a placeholder. And basically, you end up wanting to remove the pass and put in the code that you want, or if you don't have any code to put there, just get rid of the function. But you shouldn't leave pass in your final code. It's just a placeholder. Okay, so I've defined my class. I do actually need to do something with a class after I define it. So even for the most complex games, to get it to run, usually use code like this. I basically define a main method, create an instance of the class, call setup, and run it. That's about all there is to it. Okay, sprites. Sprites represent items on the screen you can interact with. In this screenshot, every single coin is a sprite. The player is a sprite. We manage sprites in lists. This makes it easy to detect collisions and to update objects on the screen. Now, let's go over the code for a simple program where the player can move around collecting coins. It's easy to write code to create a sprite. Section 1 here creates the sprite. All we need is an image on the disk. We give it the path to the image on the disk. Optionally, we can also give it a scaling factor. So if the image on the disk is too big or too small, you can scale it up and down. Section number 2 positions the sprite. And 3, we add the sprite to a sprite list. Sprite lists are really important in creating your game. There are a lot of built-in optimizations underneath the hood around the sprite list. We use things called vertex buffers and texture buffers that allow us to turn thousands of drawing calls, if you have a lot of sprites, down to one drawing call to your graphics card. It's particularly beneficial for any groups of sprites that don't move, like walls, platforms, that type of thing. And you should always group sprites into sprites that move and sprites that don't move, or some other grouping. But you don't want to group sprites that move with sprites that don't move. You can also use sprite lists to detect if one sprite is touching another sprite. And there are optimizations behind that. Because if you think about it, if you have a character or some other item in a game that's moving around and there are a lot of walls, You could like have 1,000 wall sprites. That means 60 times per second, you need to make 1,000 checks to see if it hits any of those walls. Sprite lists have built-in spatial hashing, so it actually keeps track of what sprites are close together so that you can take those 1,000 calls and just make a few calls. Lists also make for easier sprite management so that you can basically keep lasers separate from walls, separate from characters, coins, enemies, that type of thing. Okay, the next bit of code puts the 50 coin sprites in random positions on the screen. The loop, number 1, runs 50 times. And the part number 2 positions the sprite into a random location. And we can use similar techniques to place sprites in like a grid or some other pattern. So, as you can see, it's really not too hard to do this. Drawing with sprites is easy. The onDraw command in my game class just looks like this. I call start render. I start going through my sprite lists. You draw them in a back to front order. So in this case, if I've got a wall and a coin in the same place, the coin will be drawn on top of the wall because I drew the wall first. Sprite collisions. You can detect if a sprite is hitting another sprite easily with the check for collision with list function. I'm giving it 2 pieces of information. My player, the list of coin sprites. It's going to return a list of every single coin I'm contacting, if any. Then all I need to do is a loop through each coin that I'm contacting. In this case, I call the kill command, gets rid of the coin, and then I add 1 to my score. This is easy code. Okay, but I haven't yet said how to move sprites. How do you get sprites to move? How do you get the player to move? Maybe we want to spruce up our game and have the coins move down, something like that. Well, before we get into that, let's just sort of briefly talk about the coordinate system. If I've got a window, 800 wide, 600 tall, lower left corner of that window is going to be 0, 0. Upper right corner of the window is going to be 599, 799. Of course, we computer scientists always start counting to 0, so there's not actually an 800 and 600 at an 800 by 600 window. Anyway, if the coin falls off the screen, off the bottom, then I know that the top y coordinate of that sprite is going to be less than 0, right? So when it falls off the bottom, I'm going to need logic to respawn the coin, and I'm going to re-put the coin somewhere up above the screen so that it can slide back onto the screen. I'm going to do that somewhere 20 to 100 pixels above the screen in that top box there. Then the coin will just slide on. Okay, simplest part is moving the player. Moving the player, if you remember, there's an on-mouse motion function in the window class. Just take the player sprite, set its center to where the mouse is, and you're done. That was easy. Okay, the coins, though, the coins aren't quite as easy. So in order to move the coins, I'm going to, step 1, create my own custom coin class so I can control the movement. I'm going to derive from Arcade Sprite class, so I get all the sprite functionality, just need to add to it. Skip down to step 4. Here, I've got an update function. There's an update function in the Sprite class. There's an update function for the window class. This is in the Sprite class. This update function is going to be called 60 times per second. Every time it's called, I take the y coordinate, subtract 1. So at 60 frames per second, I'm going to move 60 pixels per second. Want it to go faster? Use a number bigger than 1. Want it to go slower? Use a number smaller. Not too bad. Skip down, or part number 5, basically, yeah, okay, I did that, sorry. Part number 6 sees if the y coordinate of the top of that sprite is less than 0. If the y coordinate is less than 0, it's moved off the bottom of the screen. I'm going to reset the position. That's where we're going to jump up to part 2. And in part 3, there, we basically just run the random number generator again, giving it a random spot somewhere 20 to 100 pixels above the height of the screen, and then it'll eventually slide back onto the screen. Okay, we're not done yet. I've created a coin class. I need to actually create instances of the coin class. So back where we created the 50 coins, I need to take out where I create arcade sprite, cross that out, and put in my coin class. This is actually one of the most frequent mistakes I get with new programmers. They create the cool coin class that does everything that they want with their enemy, and then they create something else totally different and never even use it. And the sprites still won't move, though, because I need to go back to the update function in the window, and in the update function of the window, I need to add part 2 here. I need to call update on all the coins. So I call update on all the coins. Now the coin update methods will run. The coins will move down, and I've got moving coins. Okay, that's a dead simple example. What sort of other things can you do with it here? I need to start this. Cool, okay, so you can create platformers. This should work here. There we go. Yeah, you can create platformers. You can create platformers with ramps, moving platforms. There's a PyMonk library for 2D physics. Really cool to integrate that with this, so you can do the 2D physics. And then I had a student, first semester student, create a tower defense game, which theoretically would come up if the Wi-Fi didn't convene. Yeah, there we go. This is a really intense game where there's all sorts of sprites, all sorts of explosions. You can actually move yourself around there and cast spells, and the internet, of course, is not working while I'm doing this. But anyway, trust me, it's like really cool. And anyway, it was a pretty amazing job. You can create huge scrolling maps as well. I've got an example on the later part of the video where we're moving around a really large procedurally generated dungeon with 10,000 wall sprites. Arcade keeps up with it just fine. Okay. One of the best ways of learning is not by textbook, but by example. There's a lot of example codes, all oriented towards teaching you particular techniques. I've taught intro to programming for like 10 years now, and all sorts of students have asked, hey, how do you do this? Hey, how do you do this on the video games? And I've created a library that basically shows code samples on how to do it. So if you want a Space Invaders type game where you have somebody at the bottom shooting lasers going up, example for that. If you want to aim the bullets, examples for that. If you want to spruce up your game and have enemies fire back, well, I've got examples that show you how to have the enemies fire back on regular intervals, random intervals. You can actually have them aim at the player. And then, of course, what good is any type of game without explosions? So we got to show you how to do explosions, right? If you're in more of an adventure type game, I'll show you how to do games where you don't move through walls. You can have players move around. You can put coins in your game randomly, but not on top of walls. You can do scrolling screens. Scrolling screens are really easy if you want a side scroller or a top down where you only see part of the world at a time. Not difficult at all. You can animate sprites, get their little feet to move, get the coins to spin, that type of thing. You can use a map editor, do ramps, platforms. There's a lot. You can also, besides having sprites move down, you can have them bounce, move in circles. You can have them rotate. And I get a little bit into procedurally generated mazes, which is a great way to kind of get an eye on for like recursion. You end up using recursion out of that. Some cellular autonoma for the procedurally generated caves. Anyway, it's fun, and there's a ton of examples out there for being able to steal from and make use of. Okay, so what's next? This is the arcade library, and there's new things coming all the time. The most recent updates are going to include isometric map support, so it's kind of like the fake 3D version, and there'll be support for that. We do have examples on how to use the tiled map editor. The tiled map editor, if you haven't used it, is a great free resource to lay out dungeons online, or not online, but you can use a program, download it, lay out your dungeons. And while there's some support for that, there's going to be really good support pretty soon where it'll easily allow you to save and load up maps created in that editor. In addition, eventually we plan on adding better support for decorators, particles, effects, and lighting and shaders are hopefully on tap here soon too. I often get people that ask me questions, how does this compare to PyGame, which is a little bit more well-known? I taught with PyGame for a really long time. I love PyGame, but PyGame is really aged after a while, and I spent time teaching some of my efforts around how to get around the weird things with PyGame when I really wanted to teach computer science. So I've worked really hard at everything that I learned out of teaching from PyGame, and I want this arcade library, I've made it simpler and easier to use and tested it with all sorts of new programmers to make sure that they can get games up and going easier than they could with PyGame, which by itself is pretty easy. It also uses OpenGL rather than an old SDL1 library that's out of date and nobody supports anymore. And it uses Python 3, type hinting, decorators. You don't have to manually create an event loop. It just promotes better programming. If you think you might be interested in contributing to this, the GitHub is there. The documentation for that website is all built via the stuff that's in GitHub. So if you are just new to doing pull requests or you want to do a simple pull request for changes like for changing grammar or something, this would be an awesome project to get started with and doing that. There's also an open source book available in teaching a person how to program from no programming up to being able to create nested loops, array-backed grids, that type of thing. That's also linked to on the website, and all the source code for that book is also online, and I've worked on that in some form or fashion for about 10 years now. So if you want to take a look at that or suggest contributions, that would be cool. Okay. And if you want to contact me, I would love to talk to people about Python and get a hold of me after the conference. Send me an email, send me a tweet, go onto the website. There's also a support group on Reddit. If you do Reddit, you can go on Reddit to that particular group, ask questions. All great. I would love to hear from you. Any comments, criticisms, suggestions, that type of thing would be wonderful. So that's all I've got. I don't know if there's time for a question or two. Yes. Okay, cool.
For 2 or 3 questions.
Thank you.
Hi, thanks. That was really cool. Can you tell me a little bit about distributing and sort of packaging and distributing games for others to play with this library?
Oh boy, I wish I could. It's not good. The end result, it's not easy to do. I'm not going to lie to you with that. You would really need to put Python in one directory, the game in another directory, and create a file to start it. It's really the only way I know. CX Freeze and those types of tools, I've not tried myself.
I saw that you were doing a lot of work using the actual pixel location. Do you handle scaling for high-resolution displays?
Yeah, actually, since it's all OpenGL, you can actually easily use OpenGL to scale the display up and down. All you need to do is set the viewport to something other than pixel by pixel resolution, so you could scale it up or down that way rather easily.
So I volunteer to do the Hour of Code at my daughter's elementary school, and one of the challenges is that they're all in Google Classroom, and the systems administrators lock down all their computers. They can't actually load the Python interpreter. So I'm wondering, have you seen solutions to this where you can run the Python in an interpreter on the cloud, for example, for kids, like a safe space for kids to run Python?
Yeah, unfortunately, I don't think this would be a good solution for that, particularly with the OpenGL requirements and the graphics. This would not probably work well at all. I haven't recently tried running this on a Raspberry Pi. I would almost kind of wonder if something like that would make it possible to do cheap computers where people could have their own separate item. But for running it in the cloud, I really don't know of a solution, particularly with this.
Thank you.
Looks like all the questions. Thank you so much for a great talk.
Thank you very much.